All right, we're going to do some beam work right now to kind of demonstrate working with beams both on the pre-processing side and the post-processing side in Femap. Here's a sample model I'll be using. This is a solid geometry, and I'm going to use this for a bunch of examples, but give you an idea, kind of a stiffened structure with some fittings and little backup fittings and rings and things. So what we're doing here is instead of doing the whole thing, I'm just going to model an eighth section, then rotate it around. And just to give you a quick idea, you know, a lot of this was mid-surfaced. So if I do mid-surface automatic, pick this solid here, ask me for a thickness, and I'm just going to measure from there to take a guess, tell it to combine, and pretty quickly you can see how we'll get to a mid-surface. So show selected only. So I'm down to a nice connected mid-surface there, and then use some tools. We got some great tools in Femap for splitting up a mesh in order to get just an absolutely perfect mesh. So in the meshing toolbox, you can put pads around holes. You can connect these up to the outside, up to the inside, and then if you want to get tricky here, I can do to there, and then do a point to edge or point to point. And then in the meshing, I can say a mat mesh 0.4 and just start blasting in some meshes. Got to turn the elements on. Let's go down to a 0.25. And then we can just box pick. Say we are, let's just say we want to box pick here. Mesh this guy, this one, and this one. So you can see how quickly you can lay down a nice mesh. And then sizing wise, turn it up around the hole, turn it up here. You can work on your mesh quickly. So I've done some of that work already. All right, let's move on to actually putting the beam cross section on this. So what I've got here, here's a model where I've already done all that mid surfacing and some of the pads and such to lay down just a really nice mesh. So what I'm going to do now is get that beam stiffener on there. Now there's a lot of things we could do. We do have the stiffeners in here as a solid, so I could actually set up a mesh size on him, given some reasonable mesh size here. That's a little bit light, so let's go ahead and pick him again and just go 0.3. And it's still light, but we'll just let it fly. So we can obviously tap mesh him. Just let me change this to front so it picks the front guy. We could tap mesh, lay down a mesh on him. You can see that adds a lot of elements really quick. So let's get off of that, not tap mesh. The other thing we could do is I did hex mesh it just for fun, split it up a little bit, and I hex meshed it, and we could actually use our model merge and actually bring this this hex mesh right into the other model. But again, that's 73,000 nodes, so it's adding a lot of degrees of freedom. So what we're going to do is let's go ahead and just beam model this. We could certainly mid-surface it and do that, but let's go ahead and just beam model this. Now I have set up a group in this model already that has the curves in the back there for setting up. Let me turn that on, show you the group. I turn my highlighters on and pick my group with the stiffener curves. So I've already put those curves back in our group. So what we're going to do is we're going to run a stiffener as beam elements, node to node beam elements right along that curve. And then we'll merge the nodes in to use to connect into the rest of the mesh. So here's kind of the couple of the real key tools we have for beam modeling in Femap. First one is calculating the section properties for this fairly complex section with the blends and stuff and the curvature. Just be a little bit difficult to calculate by hand. So let's just go create a new property. And if you knew all the inertias and stuff and areas, you could put them in, but we don't. So we're going to say shape, and we're going to do a general section. And here's a really neat thing. This will control the reference point, which is where the beam will ride along in your model, and you'll see what this does in a second. But I'm just going to pick that cross section. It wants a vector to align it to, and I'll just use the edge of the stiffener itself. And then it wants this reference point. So I'm going to go pick the point along that curve right there. So we got that. and that'll put the reference point in the cross section, and that way the offsets will all be set up from that reference point, so I can get this thing right in the right place. So I'll say OK, and you can see Femap calculates some pretty complex stuff there, including the torsional stiffness. It does a little mini fun and element solve to do that, but we calculate that. All right, now we're going to pre-assign that property to the curve so we can make sure they're in the right location. So we got a command in Femap called mesh control, and it's the attributes along a curve. This defines how a curve will get meshed when it gets meshed. I don't need to pick them. I've already got them in a group, and I can just double check, and they highlight fine. Or actually, they don't highlight. Let's do that more and highlight. So there's my curves. Say OK. Now the property, we just picked the stiffener we just created, and I'm going to locate its orientation, which would be its rotation about the nodes that define it, and then I'm going to use the reference point to define its offset. So I'll say OK here, and I'm just going to use the same 2 points that we used before. That'll guarantee me that the section is aligned correctly. And then I think that's it. So they're on there. Let's turn off our solid, and the thing we can do now is let's turn on cross sections, and we can see, hey, look, he's already there. He's in the right location. And just verifying along the long curve there. It doesn't draw it all over. Oh, there's one reverse down here. Now this does follow the curve, so in a non-symmetric cross section, obviously it depends on which way the curve's going. So one curve is reversed. So we'll go mesh control, attributes along curve, pick that one curve that's reversed, and just tell it I know he's reversed. Get him fixed up. So now he's in the right location. So now we've got the mesh control set for those curves. We can just pop the beams on there. So there's mesh geometry curve, and I'm going to again pick that group, say OK, and it knows something's already assigned, doesn't ask any more questions, and just pops the stiffener on there. And now what I'll do is the final step will be merging the nodes to get everything connected. So just to double check, we'll do a tools check coincident nodes. Just select everybody since this is our whole model. Do a preview. We see the preview does show that whole row of nodes is going to get merged in. So we'll let it get merged in. So now this model's complete. I've got it all set up. It's actually have a constraint already at the bottom. So now I'm going to rotate this around. I'll apply a loading up here at the top. All right, I rotated everything around. I've now got a full model. It's about 55,000 nodes total, so not completely unreasonable size. But what I'm going to do here is I'm just going to put 3 orthogonal kind of simulated a high G loading in each direction. So I've already created the X load. What I'm going to do is just copy that load set and copy it again. And I'll come in here and just edit its title and call it Y load. And then go edit the load itself and just say edit load and just go 0, 1000 and Y, and then we'll do the same thing down here for Z, and let's delete that and just say Z load. So I'm just basically copied one output set and then just going to edit it, and we'll go Z. So now I've got 3 load sets. And just let's just run Nastran on those 3. So I'm going to create a new analysis. Let me delete all the other ones I already got in here. I was playing around with some other stuff. So I'm just going to create a new static load set. And what I want to do is multi-set. So we take our 1 constraint and our 3 loads and create 3 Nastran subcases. And then on the output side, I do want to get forces. So I do have forces coming out. And just for fun later on, in case we end up doing some free body work on this, I'll turn on the force balance as well. So with the multiple rigids connected to each other in here, there's a nice little option that NX Nastran has. I'm going to do this auto MPC that just kind of resolves degree of freedom things across rigids so they don't bomb out in Nastran. And anyone that's had to check the dependent and independent degrees of freedom will appreciate that feature. But now that's on, so we'll just hit Analyze. Femap writes out the Nastran deck. Nastran starts running. You can monitor as it's running the various files. Once the solver starts, you can watch the solver. This is pretty much going to solve once and apply the 3 load sets, then crank out all the results data. So that's done. Nastran is done. The monitor is actually waiting for Nastran to finish, then reads the results. And the results were attached to, and they're all in right now.